Hello and welcome. In the world of combinatorics, or this study of counting, there are lots of patterns that begin to emerge and lots of useful ones. Now, Pascal, as you might know, a mathematician, uh, had this sort of interesting idea. And we'll just go ahead and start off with the idea itself, and later we'll add to the significance of why we would even want to consider this. But if we start in a first row of what we're going to call a triangle, and we place a 1 in there, and then in the second row, if we place 2 more 1s just like this. So you can already see we're starting to form a triangle of numerical coefficients. Now, in each row, the end values are always going to be 1s. And in the center, we're going to take the sum of all the pairs of values above it. So in this case, if you add 1 and 1 together, you're going to get 2. And now in the third row, we proceed in the same fashion. Our 2 end values are 1. And now we're going to form sums of the pairs of values in the previous row from left to right. So the first pair that we can consider is 1 and 2. And 1 plus 2 is 3. And the next pair of numbers we can consider, they have to be adjacent, are 2 and 1. And 2 plus 1 is also 3. And if we keep proceeding in this fashion, we put 2 1s at the end and then form all the possible sums that we can from left to right in the previous row. In this case, 1 plus 3 gives me 4. 3 plus 3 gives me 6. And 3 plus 1 gives me 4. And so you see that in each subsequent row, we just really have one additional value than we did in the row before it. And just to complete this a little bit further, let's put 1s in the fifth row, 1, 2, 3, 4, 5, excuse me, the sixth row, and now we'll form all pairwise sums from left to right in the previous row. So in this case, 1 plus 4 is 5. Then we'll have 4 plus 6, which is 10. And now we'll have 6 plus 4, which is also 10. And finally, we'll have 4 plus 1, which is 5. And if we continue going in this pattern, in this fashion, we're going to have massive triangles that can exceed a certain size. And then the question that I might have at this point is, how do I know what the values in the nth row will be? And what I mean by the nth row is this could be the 10th, this could be the 100th, it could be the 1000th row. So n is going to be an element in the set 0, 1, 2, and so on. Now, we say 0, and you might say, well, what about, isn't this row the first row? Well, it can be, though we're going to refer to this as the 0th row. And we'll refer to this as the first row, and the second row, and so on. And this question can actually be answered using counting techniques, and we'll address that in another video. At this point, we may be asking ourselves, well, what's the point of this? What value will this have in helping us count, and more importantly, problem solve with it? So in the next video, we'll take a look at how this actually applies to polynomial expansions. So let's go ahead and do that in the next video.